Hey, what's going on, everybody? And today we are going to look at the electrical and lighting systems in the DCS F-4 Phantom. Alrighty, and before we jump into the jet, we just got to go through this diagram real quick because this will help make a little bit more sense of this. This is a very complex electrical system on this jet, and you'll see that it's referring to both AC and DC power. That's alternating current and direct current, if you're not familiar. And the way you want to think of that is AC power comes off of a generator, DC power comes off of either a battery or what is known in this airplane as a transformer rectifier. And if you've watched the live action F-4D videos that I do every weekend, you've likely have seen these at some point in the past when we've pulled them out. They're located behind the Wizzo seat. The transformer rectifier can be thought of as a very large DC power supply that is powered by the AC system. Now, the AC system can be broken down into the instrument AC system. The warning lights also have their own AC power. You have the left main AC and the right main AC power systems. Over on the DC side, you have the left and right main transformer rectifiers, or power supplies, if you will. And they have their own DC buses that they power. A bus is just one segment of the system. For the DC buses, you have the armament DC bus, you have the main DC bus, the essential DC bus, and then the battery bus. The battery bus is live at all times. There's not much connected directly to the battery, but there's a couple of important things, and we'll see that when we jump into the aircraft. The battery bus and the essential DC bus can be connected together, and in the case of a dual engine failure and your electrical system goes down, the battery will power whatever is on the DC essential as well. Now, the generators are controlled by the generator switch panel with their respective switches for both the left and right generators. The transformer rectifiers are powered automatically whenever the AC buses are powered on. So there's no switches that you need to worry about for those. All right, so that takes care of that. Let's go jump into the jet and see how this all works together. Alright, here we are in the cockpit, and before I call the crew chief and have him start up the Dash 60, I want to highlight two things that you can do with the lighting before anything. Recall that the floodlights are directly tied to the battery, and that is this switch on your right console. And that will turn on your white floodlights. You don't need to switch on anything else because these are tied directly to the battery bus. Do note that if you leave these on for far too long, and I'm talking a couple hours, that you can run down the battery. And we also have the flashlight that is aimed with your mouse, and that is accessed with the default keybind of left, alt, and L. L as in Lima. And you just turn that on and off, and now you have a flashlight that'll follow your mouse pointer so you can find all the switches that you need to switch whenever you're doing a night mission. Alright, so now we're going to look at ground power on this aircraft, and that is provided with the good old Dash 60. And not only does the Dash 60 provide our engines with the start air that we need to get them spun up so we can start them, but it can also provide the electrical power that this aircraft needs. Now, that was more of a maintenance function, but it is also useful for pre-start activities, so it's also used for that. But what we want to do now is call up our gesture menu and look for the crew chief. There it is. Notice that it says hand signals. That is because our intercom isn't turned on yet. Intercom is on the DC Essential bus like we explored earlier. Now, the DC Essential is either powered by the transformer rectifiers, notably the right-hand one, Alternatively, it can be connected to the battery bus. And the only way that happens is with an engine master switch. So if you turn on either one or both engine master switches, your intercom or ICS system will be powered and you can actually hear the crew chief talking to you. But I'm just going to call him, give him some hand signals, external power, and tell him to connect it. I gotta say, that Dash 60 sounds oh so familiar. Alright, so that's up and stabilized, and remember, since we don't have the intercom running right now, we can't hear the crew chief. Normally he would give you some hand signals and tell you that the ground power is connected, and at that point you come over here to your generator control panel, and the up position is left hand and right hand generators, but the down position is external. And a big note here, both switches need to be in external power in order to actually connect external power. So that's a left click to set them down. And we hear some instruments start spinning up, and you probably heard Jester in the back seat there clicking a few switches. I'm going to get into that because remember that diagram earlier also showed an instrument AC bus. Let me jump in the back seat. Alright, so here we are in the back seat, and for you human wizzos out there, once you get good stable ground power, you want to look over here on your right console on the cockpit wall. Notice that we have this switch down here that's labeled instrument ground power switch. And currently it's in the up position. It's this lower one on it right here on this side. Ignore the one that has the yellow and black stripes. That's the battery disconnect. But this bottom one right here on the right, that is what will connect the ground power to the instrument AC bus, so it can spin up those instruments and we can get some other stuff going on the jet. Normally that system's powered by the left-hand generator. And as long as that is on, that is powered. Now, this one special note on this switch, as soon as ground power is switched off, that switch is magnetically held by a solenoid, and as soon as you lose ground power, that switch will release and go back down to its off position. It works just like that in the real jet too. Alright, one thing that Jester did do is, this is very important if you don't have the stored heading alignment option checked in your mission editor. If you have to do a full alignment, being on ground power speeds this process along, because putting the inertial navigation system in standby starts warming up the gyro oil to 160 degrees so that it speeds along. It helps you get your alignment done quicker by allowing the oil to heat up while you're on ground power and before you shift over to engine power. Alright, so that's the power in the back seat. Let's move back to the front. Alright, so here we are back in the front seat, and let's take a look at some of our options and controls up here. One thing I want to point out is the generator status panel. This is this little red lit panel right above the tailhook handle. We see two lights lit currently, left-hand gen out and right-hand gen out. Makes total sense. Neither engine is turning right now, so the generators aren't turning. And not only that, they're not even switched on. So it makes sense for those lights to be turned on right now. Now the third light is the bus tie light. That is what connects the left and the right-hand AC buses together. On ground power, this is completely normal that light is out, because ground power comes up, powers one bus, and that bus tie is automatically connected when you're on ground power. As I mentioned, ground power allows you to knock out all of your pre-flight checks, gets your inertial navigation oil heating up if you're having to do a full alignment, and it just helps speed things along without burning your jet fuel by running your main engines just to power the electrical system. Alright, so that is ground power. Well, let's look at what handing off to the engine generators looks like from ground power. And let's call the crew chief and tell him to... Oh, air source.
Roger.
So now with ground power enabled, we got the intercom system working.
And connected on the right.
And we can hear the crew chief now. Alright, let's tell him to start up the airflow.
Done.
Yep. Right engine RPM is on the rise. %, hold the igniter over the hump, ignition, and back to idle. Now, one thing to note with the engines that if your engines ever run out of gas or they shut down in flight, at 53% RPM, the generator will drop offline. Alright, that's one good engine start. Now let's switch power. Now remember what I said earlier, that both switches have to be an external in order to take ground power. As soon as either switch is moved from this position, ground power will be dropped. You'll see that on the displays and panels until I turn on the generator. There we go, lights go out. And we got generator power. Now, the right-hand gen light is out, but the bus tie light is also out. The system will configure itself, if able, so that the whatever generator is online will power the other bus.
External power disconnected, sir.
Alright, thanks, Chief. Alright, now that the left-hand engine's running, now we can switch on its generator. Right-clicked. Now, one thing you may see whenever I switch on the left, you may see the bus tie open light light up briefly. This is because the engine generators have to synchronize to each other. So, one note on that is, so the generators themselves are on constant speed drives at the very nose of the engine. The engine itself, its RPM can change anywhere from 65% all the way to 100% at no power. The generators need to always turn at a constant RPM, and in the case of our generators, it's 8,000 RPM. So both of them have to spin at the exact same speed, and they have to be in sync with each other in order to be connected together. And that way they both share the electrical load. So you may see that bus tie open light light up briefly. That's the frequency control system synchronizing them to the point that it can connect the two together. Oh, there it is. Bus tie open. They synchronize, and then that light goes out. Now, when you do the functional test of the system,
okay, ready for alignment?
You briefly switch off the right, verify its light comes on, and then put it back online. And
yep.
Go for it, Jester.
Alrighty, what alignment do you want? Okay, go ahead, and it is.
Alright, Jester. Alright. So that is your electrical system right there. Now, in flight or on the ground, if your engine's ever shut down, it basically, once the RPM of the engine falls to about 53%, the generators themselves, the constant speed drives, no longer have enough RPM in order to maintain 8,000 RPM, and if they can't maintain 8,000 RPM, they will automatically drop offline. The system will not allow them to go under frequency. So it is normal that you'll get a gen out light when that happens. And I can simulate that on the ground just by shutting down an engine. So I'm just going to pick one. I'll just do the left-hand engine. You notice that the bus tie open light lit up briefly as the generator wound down. And now I have a left gen out. So the system reconfigured itself. Now the right-hand engine is powering the entire electrical system, which is normal. The generators are sized enough so that they can do that. That may have just messed up my alignment a little bit, but that's good for the demonstration there. That is entirely normal. Now, what happens if you lose both engines? Well, not much you can do, and I hope to God that it's not in flight.
Prime sync clear. Go ahead. Ready to taxi.
Sorry, Jester. Power's going out. Alright. So now, with both generators dropped offline, most of the aircraft will power down. Alright, now hopefully this scenario doesn't play out for you in flight, because the Phantom has an abysmal glide ratio. It flies like a brick without any engine power. And as soon as the generators drop offline, almost your entire electrical system will shut down. And the emergency procedures in the manual is very brief on this, and I'll paraphrase it. If you have sufficient altitude, you can try to restart the engines using a windmill restart. The next step is, if you are at low altitude or the restart was unsuccessful, eject. It's very short and easy to remember on a dual engine out. But if this does happen in flight, fear not, because you have battery power still available. Your battery bus is still powered, and also with your engine master switches in the on position, the battery is also connected to the DC essential bus. And I have the list here on screen on what actually gets powered off of the battery, but the big thing is that your ejection light is running. You still have control over your slats and flaps. Hopefully you still have hydraulic pressure that'll still move those for you. Again, if you're windmilling the engines, your hydraulic pump should still be turning, and you should have limited hydraulics in that scenario. Your intercom will still work. Your landing gear controls will still work. You can always do an emergency blowdown of the gear. You just grab the red handle. I believe you right click it to pull the handle out, and that'll activate the emergency blowdown on the gear. Also important, your trim control is DC powered. It's a little motor in the tail that drives the trim system, especially for the elevator. And your cockpit floodlights, of course, will work, plus your radios. So another important thing on the battery system is your emergency jettison. So you can still jettison whatever you have on board if this situation does arise in flight. All right, here we are, and now we get to talk about lighting, because the lighting controls in the Phantom are numerous and not very well intuitive. So we're going to go ahead and get started with some of the easy ones. So up front in front of you, we got the radar. The radar display, you got this little slider bar on the left-hand side of the circular display. You slide this up and down in order to increase or decrease its brightness. Alright, with the gun sight, let's pull up the gun sight. You notice how it starts at full brightness and it's kind of dazzling. So over here on this hexagon shaped knob, it's the lower part of the knob here, is reticle intensity, and we can slide that up and down as needed. You just left click and drag it up and down and to your liking. So that's the gun sight reticle there. Alright, some of the other systems have their own dimmer knob, like the RWR screen brightness has its own knob. The RWR control buttons have their own knob as well, so we can adjust those as we need. Alright, so for our external lighting, we turn around and look kind of behind the seat at this, at the panel that's all the way in the back behind the compass control panel. And this is our switches, so our fuselage lights can be set off, bright, dim. I'm going to set them to dim since it's night. I'll set them to flash. Our tail light can be set down to dim, and then our wing lights, our navigation lights, can be set dim or bright as well. And that's outside. And when it's set to the flash, the fuselage lights and the tail light will flash or burn steady, depending on how you have that switch set. Alright, let me speed up some time and I'll be right back as soon as we have some darker conditions. Alright, so here we are. It's a little darker in the cockpit. And if we want to be able to see the consoles, like I mentioned earlier, you have the white floodlights that you can turn on, and that is directly tied off the battery. You also have the flashlight, which is accessed with left control, left alt and Lima. And we also have the red console floodlights, which is this switch in the back corner. We can set it up to the full bright position, and that'll light up our cockpit, and we can set it to the medium intensity position. But we also have this dim position, and we notice that they're off. All right, this is one of those nuances with the lighting in this cockpit. When it's in the dim position, it will follow the position of the knob that's right underneath it. So we grab this knob, and we can adjust our lighting as such. So that handles a lot of our edge lighting as well on the consoles themselves, plus the floodlights. They're tied in with this knob. Alright, now if we look up on the cockpit wall, we have another switch panel. This is our instrument floodlights. That'll light up these lights up here on the instrument panel. They are colored red, and we can set them dim, off, or bright as needed. Now, if you want to change the brightness of your angle of attack indicators, that's this knob right here. Our formation lights is this knob right here. Per the manual, formation lights are never to be used on the ground. The lights will overheat pretty quickly if you use them on the ground. It also says not to use them during the daytime, not because they'll burn out, it's just they're not easily visible in the daylight. Alright, we also have our instrument lighting, and that's this main knob right here. And that lights up all of our instruments and dials. Now, we have this instrument knob way over here that says flight instruments. This knob defaults to the off position, and it controls a few lights. It'll control the lighting of 6 of our primary flight instruments, that being our airspeed indicator, angle of attack, our HSI, ADI, the altimeter, and the vertical velocity indicator. Now, it also has a switch built into the knob, and you notice right now all of my indicator lights around the cockpit, the gun, the missile status that's indicating heat, our navigation mode, the radar, and the warning light panel are all at their bright setting. If I turn this knob to any position other than off, that will dim every single indicator in not only the front seat, but also the back seat. What's happening here is normally all the indicator lights are driven with a 28 volt AC signal, and as soon as you turn this knob to any other position, it will shift that to a 14 volt power, and that's why they all burn dimmer. So that is the dimmer for your lighting, is that knob right kind of tucked behind the stopwatch. Alright, and finally, your landing and taxi lights are located on the left-hand vertical panel. Up being the taxi light position, middle's off, down is landing light. Alright everybody, hope you guys found this guide helpful. Thank you guys for watching, and we'll see you next time.
knots. Speed 100.